Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem which says let S be the set which contains 1 to 20. A subset B of S is said to be nice. So, these guys are talking about subsets. Okay. So, if I'll ask you, find out the number of subset of set S. So how will you respond? Sir, it is 2 power n and the number of elements is 20, so 2 power 20. So the total number of subsets is 2 power 20. Now, we have subset B of set S. They are going to call them as nice if the sum of elements of that B is 203. Okay, then the probability that the randomly chosen subset of S is nice is, so you have to find out the probability of getting a subset as nice. So what is this nice? So nice are the subsets whose sum of elements is 203. So first find sum of elements. Sum of elements. So look at this. So all numbers are 1 to 10, all or 1 to 20. So 20, 21 by 2. So it is 10 times. So we got 210. Okay. Now try to understand that we want sum to be 203. So there are two ways. Either find out the elements whose sum is 203, or you have to remove some elements from set S so that the remaining element will end up having sum as 203. So what I will do, I will remove 7. Okay, so we will remove 7. So suppose that I have to remove one digit. Okay, so if I'll remove one digit, I'll remove 7 and we are done. Okay, so single digit is done. Now we will think about two numbers whose sum is 7. So it is 1 and 6. Then we have 2 and 5. Then we have 3 and 4. And you cannot interchange the digits. Okay, because you are removing. So you are removing which number first doesn't matter. Okay, you have to remove combination of numbers. Okay, so this is your two numbers. You are throwing two numbers whose sum is 7. Now I would like to throw three numbers whose sum is 7. So I'll throw 1, 2, this is 3, and 3 3 6. So you know it is not the case. Now I have to remove 4. Okay, so 1, 2 and 4, so 7 is done. Now if you will think that I have to remove 4 digits to make 7, the minimum is 1, 2, 3, 4, which will sum up to 4 into 5 by 2, yani 10. So you cannot remove 4 numbers so that you can end up making uh, the sum as 7. Okay, so these are the cases. So these many ways by which you can remove sum 7. Okay, indirectly means you are keeping those numbers whose sum is 203. Therefore, can I say that the total number of selection is equal to the total number of rejection? Okay, and the total number of rejection is 5. Okay, I hope the idea is clear. Therefore, the required probability is, look at this. So total favorable outcome is what? 5, and total number of possible outcome is 2 power 20. Therefore, the required probability is 5 by 2 power 20. I hope the idea is clear and you guys can handle similar situations. So See you guys in next session of MathFlix.